Hello everyone. So if you remember last class, we talked about integrals to infinity in the three cases. Well, I had a lot of questions last night on this one problem, and so I thought we'd start off the class with it. 0 to infinity, x arctangent of x over 1 plus x squared quantity squared. So this was one of your homework problems last night, if you didn't look at your homework, but a lot of people had questions on it. So the first thing we want to do is, looking at this, decide what case we have. Well, if we notice, there was no negative infinity, so it's definitely the first one. And we were starting with 0, so 0 to infinity, a would be 0. We're taking the limit as t goes to infinity of a to t. Then it's an integral we can take. So the first thing we need to do is rewrite that. The limit as t goes to infinity from 0 to t, x arctangent of x dx all over 1 plus x squared squared. Okay. Now we need to try and simplify some more. Well, what if we can get rid of this inverse here, the inverse tan? Remember, if you take the arctangent of the tangent of, I don't know, theta, it gives us theta. And so we could substitute here, and that would help simplify this. If x equaled the tangent of theta. So we'll substitute. Well, when you're substituting, remember you take the derivative, and x is 1 dx. And tangent, does anyone remember the tangent? Tangent is secant squared. And we plug in. Okay, so we have the limit as t goes to infinity from 0 to t. In place of x, we put the tangent of theta, and then we have the arctangent of the tangent of theta. Oops, we're going to put secant squared there. One plus x's tangent squared theta squared. And then dx becomes secant squared theta d theta. Looks complicated, but remember, this whole thing is going to reduce because the arctangent of the tangent of theta is just theta. But think about it. Remember the inverses, there's the special rules with the range, and this would be the range. The arctangent, it has to be between negative pi over 2 and pi over 2. So theta has to be between negative pi over 2 and pi over 2. So this can't go to infinity. Instead, to keep it continuous, it's going to go to 0 to pi over 2. And then we have the tangent of theta. All of this just becomes theta. We have the secant squared over there, all over 1 plus tangent squared theta squared. A little better. What could we do? We could rewrite sines and cosines and try and reduce, but before we do that, it'd be better to get rid of this. 1 plus tangent squared. What's 1 plus tangent squared? Anyone remember? You should remember because it's one of your Pythagorean identities. Right here. 1 plus tangent squared is secant squared. So we can rewrite that. 0 pi over 2, tangent of theta, and this theta I'm going to move in front. Secant squared theta all over the 1 plus tangent becomes secant squared. Now if you want, you can think of this as secant squared times secant squared, but this is going to cancel with one of them. Simplifying it some more then. 0 to pi over 2 theta tangent theta over secant squared. Okay. Now's where you want to put your sines and cosines in there. We just have all kinds of multiplication and division rather than this addition. Here's where you want to switch them around. So we can go from 0 to pi over 2. We still have theta. Tangent, someone mentioned, was sine over cosine. Secant squared, 1 over cosine squared. What do we do when we're dividing by a fraction? We flip it and multiply. We can simplify some more. So this cosine will cancel with one of those and leave theta not equals, but theta sine theta cosine theta d theta, still from 0 to pi over 2. We'd like to get it down to one trig function. And so, does this remind you of anything? At least part of it? It should remind you of your double angle. This double angle is 2 sine theta cosine theta. Well, this doesn't have the 2, so we could just divide the 2 to the other side. So in place of this, we're going to put the sine of 2 theta over 2. So theta times the sine of 2 theta over 2 d theta. Now we can pull that 1/2 out. Now we have one trig function. And what can we do? Integration by parts. We need to find our u and our dv, but we can use integration by parts. So you want u to be the simplest part so that it would break down, and theta becomes 1. So we would let u equal theta, because then derivative of u is 1 du, the derivative of theta is 1 d theta. So it breaks down nice. Well, that means then dv is the rest of it. Here we took the derivative, here we take the integral. So we get v equals the integral of sine 2 theta is negative cosine 2 theta divided by the derivative of the inside, which is 2. Okay, and then we go across and down. It's theta times negative cosine 2 theta over 2. And don't forget your 1/2. And then minus the integral of V times cross d theta. Times. Now I would pull these halves out because when we start plugging everything in, it will make it much easier. So if I factor this half out, it's going to make 1/4. Theta times negative is negative theta cosine of 2 theta. A negative and a negative makes this a positive. 0 to pi over 2 cosine of 2 theta d theta. So I just simplified it a little bit first. Now we can take this integral. 1/4 negative theta cosine 2 theta. The integral of cosine will be sine. And then remember, divide by the derivative of the inside. And we're going from 0 to pi over 2. And we just want to plug our values in. Top minus bottom. We have negative, again the pi over 2, pi over 2 cosine 2 times pi over 2 plus the sine 2 pi over 2 all over 2. Fix that. Plug in 0. Minus 0 cosine of 2 times 0 plus the sine of 2 times 0 all over 2. Okay, these cancel and leave. I'll just write it out. 1/4 negative pi over 2. These will cancel and leave cosine of pi plus sine of pi over 2. And then this drops out because it's 0. Minus the sine of 0 over 2. Cosine of pi is a -1, so we have 1/4 times positive pi over 2. The sine of pi is 0, and the sine of 0 is 0. So we have pi over 2 times 1/4, which is pi over 8. Any questions on that?